So in this video I thought that I would show you how to implement wind for the grass shader that we made in the previous video where we made the grass interaction. So this is how this wind shader looks like right now, and it works with the interactive grass that we built in the last video. So in order to continue building this shader with me, you need to watch the previous video, and then you can continue on watching this video where we upgrade it and implement wind to the grass. We're also going to use this material instance again, as we did in the previous video, and I can show you right now that we will be able to control the direction of how the wind flows with the help of scalar parameters again, and using the material instance. So this way we can have directional wind in our project shader, and that's quite nice. And this is a global direction, so all the grass, wherever we place it in the world, will follow this directional wind. Alright, let's begin, shall we? We will continue working on the shader that we built in the previous video, and nothing has changed. We still have the sphere mask and the directionality and the gradient. We're just going to apply more logic to the vertex shader in order to make the wind functions. To start, we need to use two noise textures. These noise textures will drive the wind effect, and we have those here. I will use this noise and I will use this noise. So it's important for us to drag in these two textures. You can use any noise you want, and you can generate noises, for example, in Designer or Houdini or another software. However, I got these two textures and they are packed, like there's different data packed in the different channels, and I reuse these textures just because it's convenient. But like I said, we will use this noise and we will use this noise to create the wind. The wind UV coordinates will be projected in world space. So I think it's a good idea to start making the world space projection. And to do that, we need the absolute world position again. We're gonna abs this, and we're gonna divide, and we're gonna have a scalar, no, a constant, and this constant will be set to 25,000. This will then later be masked, and we will use the RG channel. Why, you may ask? Well, the absolute world position gives us, like we talked about in the previous video, X, Y, and Z in the world position of X, Y, and Z. However, we just want to project from the top, and that means that we want a projection in X and Y. That's why we're just going to project R and G. After that, we need to add a time node. We need time in order to make the texture scroll, and this scrolling will simulate the wind moving through the grass. And I have already determined a value of 0.02 for the speed. We will then later, no, not later, we will do it now, sorry. we will multiply directions, because as I showed you in the beginning of the video, we want to have control of the direction of the wind. In order to do that, we're going to create two scalars, and we will call this scalar X and we will call this scalar Y. Now these values will be between -1 and 1, so we will never want to go over those values. That's why we're actually going to use a clamp node for this. So the minimum is -1 and the maximum is 1. And the same goes for this. Now we will make a float 4. No, a float 2, sorry. And we will connect y to y and x to x. And then we will multiply this. And we will call this wind direction. Wind direction for world space UV. Right. And now we will add the direction and time with our world space projection in X and Y, like so. And these UV coordinates that are now projected in world space will be connected to this texture. And this texture, like I said, holds this noise. However, we need world space projections for this texture as well. But we do not want necessarily the same values. So we're going to do some tweaking here. We will still need to use the absolute world position. So we will divide this by a predetermined value of 300. And we will then later mask this again, as mentioned before, these projection in X and Y, because we want to project from the top. The division node, I forgot to mention that as well, but the division nodes here are basically tiling factors that will determine how much, determine the scale of the texture we project. And we of course need time again. So we will multiply this. And we will multiply this time with 0.2 again. So now we have the world position in X and Y, but with a different tiling factor, and we have the time. And now we will multiply the direction again with our new time, and then we will add the world position projection in X and Y with our time, and then we will connect this to the UV for this texture. Alright, so in short, here we have time that makes the texture scroll, and here we have world position in X and Y projected from top to bottom. And we have different tiling factors, and we have two different textures. Alright, you can even see that they are starting to tile here in this little preview window. Now, the next step, when we have our scrolling textures in world space, projected in world space, we will use the alpha channel and we will use the blue channel. This depends on how you pack your textures, so this is just specific for me and my noise textures. So you will have to use maybe another channel depending on what noise textures you have and how you pack your noise textures. So the next step is that we're going to make wind direction again. So we make a float 2, and we need 2 multiply nodes, like so, and we need a scalar, and this will be set to -1. This is just because the UVs are inverted for some kind of reason. I actually don't know why, but this will work because we want to use the same parameters from here connected here. So we connect X here and we connect Y here. Y here, and then we connect X here and Y here, and then we can call this wind direction. Now this is a good idea to use the same scalars because now we can just change in one place and the direction will be updated everywhere in the shader, which makes it much more convenient to work with in the material instance. Now when we have our 2 textures that are added together with different projections in world space, we will add wind strength. So we call a scalar and we call it wind str. This will determine how much the grass bend, and we will determine the default value to 100, for example. Now after that we can multiply again the direction with the wind strength, and after that we can mask this out. So we need to mask 2 times because this is a float 2 and we just want X direction first and then we want Y direction. Oh, sorry, Y direction. And then we want to make a float 3. And we will connect this to X and we will connect this to Y, and then we need constant that is 0. And finally we need to multiply with our lovely gradient as I talked about in the previous video, and we make gradients with texture coordinates as always. And we connect this here. And if you remember from the previous video why we want the gradient going from black to max red here, or black to white, is that we want no effect in the roots and we want max effect at the top. Same goes for the wind. And then finally we're going to add this with our interactive function, and when we add the interactive function with the wind function we can put it into world position offset. We can then apply and save. And then let's see what happens. Alright, let's see what happens. Nothing happens. The interaction still works, but as you can see, the wind is not moving. And that is probably because we have not set a direction. So we set the direction to -1, and now we can apply it and we can save it, and then we will have wind. because if we have a direction of 0, 0, we get no effect, as always when you multiply something with 0. Right. Then, to end this, we can create a material instance again. And as you know, I always use mi. And we go to our grass plane and we call it mi, my wind grass blades. And we save it. And we can open up our new material instance. And we can make a small little window so we can preview it, and we can activate all our scalar parameters in our material instance. And now we can play around with the wind strength. This is quite extreme. We can take something even more extreme. Now we broke the shader, and we can try different directions. So if we have 0 again, you see that the grass doesn't really work. But if we have -1 and we have -1, we can get this direction, or we can have this direction, or we can have this direction. So yeah, it's done. This was maybe a bit more just looking at me applying math nodes, but I hope you followed a bit. To end things, we could probably discuss how the world space projection works actually with these noise functions. So we could take for example this channel and put it into the color and apply it, and then we can see here that we have this scrolling noise in the shader that will multiply and have effect on the shader. And then we can take the alpha channel and look at that, how that looks like. And that looks like this. So this is the wind coming in, and depending on what values these are, it will have different kind of strengths. But the nice thing is that we have our material instance here. No, we have our material instance here, of course. We can have this small little window again, and as you see, when we change the direction now, the noise direction is also changed because we connected the scalars. If you remember, we connected the scalars here, the drives. We connected the scalars here that both drives the world space projection in the UV coordinates and the direction of how we actually bend the grass, which makes this system work wherever we place grass in the world. And it doesn't matter if we rotate the grass, it will still blow in this direction that we determined because it's projected in workspace. And it doesn't matter where we place this grass either, because again, it's in world space. The UVs are in world space, so this will work for a large open world game, for example. Yeah. Well, let's reset everything and apply. And I think that's that. You can play around with the values and you could probably improve the shader math as well, but I'm quite happy with this result, and I hope you try it out. And as I mentioned in the beginning, it's really important that you watch the first video about my grass interaction in order to follow in a good way, because this was just a quick video where I implement wind. Hope you enjoy. Bye.